Hello everyone, this is the pre-launch news conference for Jason-3. We launched aboard a SpaceX Falcon 9 rocket on Sunday, January 17th. And here to discuss the launch, the countdown, and the spacecraft, we have, beginning with our program manager from NOAA, Jim Silva, the Jason-3 program manager, Sandra Smalley, Director of the Science Mission Directorate Joint Agency Satellite Division at NASA headquarters. Tim Dunn, the NASA launch manager during the countdown on Sunday. Hans Koenigsmann, the Vice President of Mission Assurance for SpaceX. Parag Vazay, the Jason-3 project manager from the NASA Jet Propulsion Laboratory in Pasadena. And Lieutenant Joseph Rao, the launch weather officer for the countdown on Sunday from the 30th Operations Support Squadron. And we'll begin first with Jim Silva, the Jason-3 program manager from NOAA. Jim?
Thank you, George. Good afternoon and welcome to the Jason-3 press briefing. I'm Jim Silva, program manager for NOAA, and I'm actually very thrilled to be here just 2 days before launch. We've been waiting for this launch for well over 2 years now. This mission could not be possible without the productive collaboration between NOAA and its partners, EUMETSAT, the French space agency CNES, and NASA. NOAA provides the launch vehicle, the launch services, 3 instruments on the Jason-3 spacecraft, all through a reimbursable agreement with NASA. NOAA is also responsible for operating the ground stations in Alaska and Virginia for routine spacecraft operations and for operational data processing, data archive, and distribution. All of the 3 things that I just mentioned are delivered by the NOAA Satellite Operations Facility in Suitland, Maryland. We also provide user services for our partner JPL, who are going to be monitoring the U.S. instruments on Jason-3, and with our partner overseas, EUMETSAT, the European Operational Processing Center for Jason data. I'd like to go over the mission overview. In my opinion, Jason-3 and its 3 predecessors, Topix Poseidon, Jason-1, and Jason-2, provide the most accurate measurements of global sea surface heights. Think of it, a satellite that is orbiting the Earth more than 1,300 kilometers away is able to tell us the height of the sea surface with an accuracy of less than 2 inches. To paraphrase from Charlotte's Web, that is some satellite. Its primary mission is to determine ocean circulation and sea level rise. Let me speak about some of the operational benefits of this mission. Our colleagues in the National Weather Service run an environmental prediction center. There are actually 7 of them, and 3 of those make use of altimetry data from the Jason series in near real time. For instance, the Ocean Prediction Center is able to collect significant wave heights and wind speed from the Jason-3 operational geophysical data records, which are the near real-time products that we delivered to them, and they're able to forecast the waves around the globe to provide particularly significant waves and wind speed that affect maritime safety and that provide for maritime safety. So The other centers are the Climate Prediction Center, which uses the observations from El Nino to depict the extent of the warming of the equatorial Pacific, which is affecting the weather patterns, not just in this area, but throughout the world. The other center that makes use of our data is the Environmental Modeling Center. This is the group at NOAA that forecasts the weather 3 to 7 days in advance. They use the hotspots depicted by the altimetry data to be able to detect where these areas are in the oceans and be able to forecast the intensification of tropical storms when they go over those warm regions. Those are just 3 examples of the operational uses of the data. The Navy also uses significant wave heights and sea surface winds to be able to provide for safe maritime navigation for the fleet. One of the advantages of Jason-3 over its predecessors is through improved science algorithms, we can generate sea surface, wind speed and current much closer to our shorelines than we did in the past. In the past, we were able to detect these features approximately 10 kilometers away from our shorelines. With the improved algorithms, we're able to do this 1 kilometer away. That's a significant advantage over our predecessors, particularly in providing for search and rescue services in case of downed ships near the U.S. shores. So, NOAA could not have accomplished this mission without the help of our partners. I want to extend my sincere appreciation to NASA, EUMETSAT, and CNES for their support. NOAA is ready for launch. Go Jason-3.
Thank you, Jim. Now to Sandra Smalley, Director of the Science Mission Directorate, Joint Agency Satellite Division at NASA headquarters. Sandra?
Good afternoon, everybody. I, too, am really excited about this mission and looking forward to launch and successful operations on Sunday. I want to commend the team, congratulate them for the hard work and the outstanding job they've done to get the team to this point ready to launch and operate. NASA has long used space as a unique vantage point to understand and increase our understanding of our home planet, improve our lives, and safeguard our future. The Joint Agency Satellite Division within the Science Mission Directorate at NASA serves a unique role. We support partner organizations and bring to bear NASA's unique expertise in space and scientific exploration to support services such as weather prediction and resources management, natural resources management. Our division's unique role is to serve as the acquisition agent for these organizations. For Jason-3, we facilitated access to NASA's expertise at the Jet Propulsion Laboratory in Pasadena, California, and the Launch Services Program at Kennedy Space Center to support both instrument development, project management, and launch services support. The Earth Science Division within the Science Mission Directorate also plays a very important role by advancing scientific understanding of Earth's systems and its response to natural and human-induced changes to improve prediction of climate and weather and natural hazards. The division, the ESD division, provides financial support to the mission and co-leads with CNES, the Ocean Surface Topology Science team. Jason-3 will extend the multi-decadal data set provided by its predecessor missions to improve upon critical global sea surface levels, wave height, and wind speed measurements. Jason-3 provides the continuity of the ocean altimetry data for monitoring the sea level rise globally. Building and launching Jason-3 has been an incredible demonstration of international partnership, as you can see on the slide. It depicts each organization's contributions to the mission. This is an international cooperation in which NOAA is partnering with NASA, EUMETSAT, and CNES. NOAA and EUMETSAT are providing the lead to this mission. CNES provides the spacecraft and 3 instruments. Similarly, NASA and the Jet Propulsion Laboratory are also providing 3 instruments. The Launch Services Program provided the SpaceX Falcon 9 launch vehicle and launch support to the mission. I joined the team in August to bear NASA's unique expertise in space and scientific exploration to support services such as weather prediction and resources management, natural resources management. Our division's unique role is to serve as the acquisition agent for these organizations. For Jason-3, we facilitated access to NASA's expertise at the Jet Propulsion Laboratory in Pasadena, California, and the Launch Services Program at Kennedy Space Center to support both instrument development, project management, and launch services support. The Earth Science Division within the Science Mission Directorate also plays a very important role by advancing scientific understanding of Earth's systems and its response to natural and human-induced changes to improve.
Down on Sunday. Tim?
Thank you, George. I'm proud to be here today representing the men and women of NASA's Launch Services Program. I'm the NASA launch manager for the Jason-3 mission, and I'm thrilled to serve as the launch director for a Falcon 9 launched NASA spacecraft that will provide ultra-precise sea surface height worldwide. After successful launches over the past 2 years here at Vandenberg Air Force Base, the NASA launch team is back on the Central California coast. Jason-3 is the first NASA LSP mission to launch on a Falcon 9 vehicle and will depart Earth from Space Launch Complex 4, the pad we call Slick 4. I'd like to recognize the Falcon 9 Jason-3 launch team, SpaceX, NASA, JPL, NOAA, CNES, and the Air Force's 30th Space Wing. This assembled group of professionals is brilliant and absolutely enjoyable to work with. I am blessed to call myself a member of this team. Over the past few weeks, the Falcon 9 team has been busy with final launch preparations. Last week, we performed a successful mission dress rehearsal and then encapsulated the Jason-3 spacecraft inside its protective shroud, what we call the payload fairing. Last Friday, the combined launch team held the flight readiness review. We assessed all preparations to date of the rocket, range, and facility assets and the readiness of the Jason-3 spacecraft. Earlier this week, the combined launch team performed a successful engine ignition and 7-second firing of all 9 of Falcon 9's first stage engines. The team then returned the rocket to its hangar where it was joined to the spacecraft. Just this morning, we held the launch readiness review, where we received approval from senior NASA, NOAA, and SpaceX management, as well as spacecraft and range agencies to continue processing toward countdown Sunday morning. At Slick 4 today, we began the process of final launch preparations by rolling the rocket out to the pad deck. Tomorrow, we will erect the Falcon 9 to its vertical launch position. Just 2 days from now, the launch team will arrive on console in the early Sunday morning hours to perform the final preparations of pressurization and vehicle checkouts. The launch team will be polled for concurrence to load the rocket propellants about 6:30 a.m. RP-1 kerosene will be loaded into the first and second stage fuel tanks, followed by liquid oxygen loading on both stages at about 8 a.m. After a series of final launch vehicle checks, we will be ready for launch at 10:42 and 18 seconds a.m. Pacific time with a 30-second launch window. I'd like to take a personal note here and tell you that one of my biggest cheerleaders for space launch is to call myself a member of this team. Over the past few weeks, the Falcon 9 team has been busy with final launch preparations. Last week, we performed a successful mission dress rehearsal and then encapsulated the Jason-3 spacecraft. I would pick up the phone when I got home to Florida after a launch campaign or when I was visiting her in Alabama, and she would go on about what an amazing job that that launch team must do, and how in the world do you do all those things. And I would try to play it down that, you know, it's just our job. But this time when I came out for this campaign and I'm sitting here today, it really is amazing work that we do. And if I have a message, if there's the next generation of a launch team that's watching us right now, this is amazing work. It's very hard work, but it is very satisfying, it's thrilling, and you'll never regret if you choose a career in space launch, putting these wonderful spacecraft on orbit. So I'd like to summarize by saying the Falcon 9 rocket and the Jason-3 spacecraft are ready. The launch team is prepared and excited to be here at Vandenberg, and we're poised to launch this important mission for our nation. Back to you, George.
Thank you, Tim. And now to Hans Konigsma, the Vice President of Mission Assurance for SpaceX from Hawthorne, California. Hans?
Good afternoon, thank you. And I just want to follow on. I'm happy to be back in Vandenberg. We launched 2.5 years ago the basically first Falcon 1.1 from here. We're going to launch another run on Sunday morning, and I'm really excited about this, partly also because this is our first NLS NASA mission, and partly also because this is a really big science mission of a really amazing spacecraft, continuous spacecraft measurements, basically that are extremely important in science and you know, for the rest of us too. So overall, I'm really happy to continue into this launch. The Falcon 9 vehicle is doing very, very well. We had, as Tim pointed out, we had a static fire on, I think it was Monday. The days kind of blur into one on launch campaign, so it's really hard to tell what day you're on. But it was on Monday. We did some data review after that. We concluded everything is in great shape, and the vehicle is really ready to go. We then reviewed again this morning and came out that we should proceed to launch. I'm coming straight from the launch pad. I took a look at the vehicle, kicked the tires off the TE, and I can say this is a great-looking vehicle. Everything is in working order, and I'm looking forward to the launch on Sunday early in the well. The launch is at a good time. The countdown will start really early in the morning, of course. So.
Thank you, George. Just to pick up where Hans left off, first I want to thank the SpaceX team for building us such an incredible rocket. It's an amazing vehicle, and we're looking forward to getting off the ground and getting into space. It's a long time coming. We've been working on this project. Personally, I've been working on this project since 2007, and so I'm excited. And the team has stayed together at all 4 partner levels and working hard to get the rocket and the spacecraft in orbit and producing data. So let me tell you a little bit about the background of the mission, if we can go to the first chart. So as we've been mentioning, Jason-3 is the next in a series of highly successful ocean surface topography measuring satellites, started by the TOPEX Poseidon mission in 1992. Then Jason-1, Jason-2, and now Jason.
Falcon 9 vehicle is doing very, very well. We had, as Tim pointed out, we had a static fire on, I think it was Monday. The days kind of blur into one on launch campaign, so it's really hard to tell what day you're on. But it was on Monday.
And extend past this existing 20-year record that we have. So let me show you on the next slide a little bit about how the measurement is done. We've used this graphic now for 20 years, since almost TOPEX Poseidon. So the measurement principle is rather simple. We have a RF, essentially radio signal that's transmitted from the satellite, bounces off the surface of the ocean. We measure how long it takes. The other thing we need to know is very precisely is what's the position of the satellite. Once you know those things and you do some fancy math, you can come up with the sea surface height. Sounds easy, nice cartoon. To actually build it, we really need a set of sophisticated. Thank you, George. Just to pick up where Hans left off, first I want to thank the SpaceX team for building us such an incredible rocket. We're flying 6 kilometers per second.
and we're measuring the sea surface height to about 4 centimeters. So this is a set of requires a set of very sophisticated instruments. I'll just point out a couple of them to you on this beautiful model of the satellite. I can lift it up because the real satellite weighs 500 kilos, and our baby's in the attached to the rocket, so I can't show you that today. But this right here is the main instrument. It's the radar altimeter. We've got the radiometer up here that does the correction for the radar altimeter signal as it comes through the clouds. And then we've got a couple more instruments with the Doris and GPS instruments in the back that measure the position of the satellite extremely accurately as we're going around in the full orbit. So let me show you a little bit about how we got here to Vandenberg and how everything has progressed to date. If we can roll that footage. So the instruments are developed in separate places. We send them to France. We integrate the whole satellite and then send it back here to Vandenberg Air Force Base to launch. Of course, we've got a whole slew of people that come out here, help unload the satellite, move it into the payload processing facility in a nice clean space, and then we go through a very careful process of course, unpacking the satellite and checking that nothing happened or changed in the process of transportation between continents, that we get it over here. We set up the whole satellite, do a whole series of checkout tests very thoroughly, carefully. It's our last chance to check the whole satellite, its operation. I can happily say that the satellite arrived here with no issues. We checked it here. It still has no issues. We've done the final sets of preparations before we've encapsulated into the fairing on the rocket, and everything's looking very good. So once we do get into space and separate from this beautiful rocket, we want to start the mission. Let me show you a little bit in terms of an animation of what that would look like. So as soon as we separate from the Falcon 9, within about 6 minutes, we'll deploy the solar panels. That'll be the first and most critical operation. We want to get power onto the satellite. We've been charging the battery here continually, getting ready for this, and then we'll start basically checking out the whole satellite. The satellite will be stabilized and then moved into a fine pointing mode, pointing at the Earth, and then we'll start the full operation of the satellite. So just to illustrate that operation, I have one more animation, and if we can roll that, I can show you a little bit. So this is purely an animation, notional animation. So we're doing kind of a strip map of the ocean surface. The red circle going back and forth is the radar altimeter that's bouncing a signal off the ocean. We're collecting that, and then basically we're orbiting, doing a full set of orbits around the whole globe every 10 days and producing beautiful maps of the ocean weather, in a sense, in terms of the ocean circulation and the sea surface height. So the team is excited. Again, thanks to the SpaceX team for accommodating us at Vandenberg. We've worked beautifully with the whole SpaceX team and the NASA LSP team with 2 sets of crews from the U.S. and France. It's worked out beautifully and very professionally. So thank you, and we're ready to go. Go Jason-3, go Falcon 9.
Thank you, Parag. And we'll look now at the weather forecast for Sunday morning. Lieutenant Joseph Rowland, our launch weather officer.
Thank you, George. So weather typically in January this time of year on the Central Coast, California, is noted by a shallow high pressure with some transiting low pressure systems moving through. Now this year it's been a little bit different. Normally we get 1 or 2 throughout the season, but of course with the El Nino effects has been highly publicized. We've had a couple more frontal systems moving through. So moving on to the satellite. So as you can see, we're relatively clear here today. We had a weak system move through last night. The next system's off to our west. We're going to see that move through this evening into tomorrow. We'll see sporadic rain showers off and on all day Saturday. But behind it's high pressure, and we're going to see that build in, and we'll see how that plays out on the forecast. So looking at the day of launch forecast slide, And then here's just another depiction of the satellite. So looking at the day of launch forecast slide, relatively benign conditions. We're going to see a little bit of cirrus cloud ahead of the next system, but
of the satellite. So just to illustrate that operation, I have one more animation, and if we can roll that, I can show you a little bit. So this is purely an animation, notional animation. So
where the primary attempt is going to be 0% with no constraints of concern. Moving on to the scrub forecast. We're seeing some lesser probabilities of violation for lightning down at about 10%, as well as thick clouds and disturbed weather also at 10%. Winds will be pretty light again, 230 to 260 degrees at 8 to 10 knots. And with the exception of the cumulus clouds and the other probabilities of violation that we're looking for, weather's looking pretty decent. And that concludes the weather portion. That's all I have. Back to you, George.
Thank you, Lieutenant Round. We'll take questions now. We'll start here in the hangar, and then take questions on the phone, and then social media. Social media can ask questions by going to #AskNASA. So let's start here in the row.
Hi, Stephen Clark from Spaceflight Now. A couple of questions, one for Hans. If you could talk about the drone ship landing attempt, why you're going to go for the drone ship versus landing back on land as you did last month at the Cape, and how you feel about the prospects for that. And also, if someone could give a cost for the Jason-3 mission, if that's doable. Thanks.
Should I go first? Okay, so drone ship landing is correct. We have just read the instruction this time for a landing attempt, and it is part of a secondary mission. The reason we don't land on land or don't attempt to land on land like we did for the last mission at the Cape is that we do not have environmental approval.
Where the primary attempt is going to be 0% with no constraints of concern. Moving on to the scrub forecast. We're seeing some lesser probabilities of violation for lightning down at about 10%, as well as thick clouds and disturbed weather also at 10%. Winds will be pretty light again, 230 to 260 degrees at 8 to 10 knots. And with the exception of the cumulus clouds and the other probabilities of violation that we're looking for, weather's looking up.
Further.
Philip Sloss with NASASpaceflight.com. I think this is for Mr. Dunn. Were there any outstanding issues coming out of the launch readiness review today, or are you pretty much clean and ready to go?
Social media can ask questions by going to #AskNASA. So let's start here in the row.
Hi, Stephen Clark from Spaceflight Now. A couple of
The team was working those through flight readiness review. We have closed those in the week between FRR and today, and we were very happy to have an incredibly clean spacecraft and launch vehicle at LRR this morning.
Thanks. And then a question about the launch trajectory. Are you going to have to do any kind of a dogleg maneuver off a Slick 4 pad? I know for the Delta launches that you had to do that off the Slick 2 pad. Thanks.
We don't do any dog legs. We go straight into a and I apologize. I should have probably said this earlier too. I was missing a slide. We go into a parking orbit. That parking, it's a two burn mission for the main mission. So you will see the standard orbit insertion that we always have into a fairly medium perigee, and then we have a high apogee, and at the apogee we are circularizing the orbit to the Jason 1336 kilometers altitude, and then the second stage will perform a deorbit burn later after that.
Hi, good afternoon. Matt Cam with CBS Los Angeles. So Falcon 9 1.1 finishing her story where she started it here at Vandenberg. Can we comment on the potential for expanding launch operations from the West Coast now?
Certainly. It is an interesting observation that 1.1 started in, I think it was September, 2.5 years two and a quarter years ago here from the West Coast, and I do remember that launch very well. And it was a pretty glorious day, and I hope we're going to repeat that on Sunday morning. And then, of course, we end the 1.1 series here at the West Coast again. Now, I do know the current manifest has more launches at the West Coast coming up later this year. I don't know the exact numbers at this point in time, but I believe it was like 3 or 4 launches, coming up later this year into similar polar or higher inclination orbits. So we will pick up our launch rate from this launch pad too. Yeah.
Any further questions here in the audience? Okay, let's go to the phones. We have a question from Irene Klotz from Reuters. Irene, if you're on, go ahead.
I am. Thanks very much, George. I have a couple questions for Hans. First of all, you said that the reason why the Falcon wouldn't attempt a land landing was just environmental. Were there any limitations on the orbit and the power of this particular rocket as well? And also, if you have any update on the status of the first stage that you were able to land here at the Cape back in December, that'd be great. And I had one quick follow-up for whoever gave us the program costs for the mission, if that $180 million included launch costs, and how many years of operations is included in that. Thank you.
So whether we could launch, whether we could land back on land, the answer is absolutely. We would have enough energy on this mission to come back to land without any issues. So it's not anything technical in this case. And regarding the booster, we got back from Flight 21 or OPCOM and at the Cape. That booster is in great shape. We inspected it. We found nothing out of the order, and we basically are going into a static fire. I'm not sure what the status exactly is as of today. We just completed it. Okay, great. Yeah, I was focusing on this mission for today and tomorrow and then Sunday, possibly Monday. So apparently it went very well.
In terms of the costs, the $180 million that I quoted earlier does include 5 years of mission operations and the cost of the launch vehicle as well.
Sorry, any more questions on the phone? No questions on the phone. All right, let's take social media now. You can still ask on social media if you like. #AskNASA. Let's go to Steve Cole. I think we have a couple of questions. Steve?
Thanks, George. How frequently does NOAA receive, analyze, and compile Jason-3 data for global or longitudinal studies?
I'm sorry.
How frequently does NOAA analyze and compile the Jason-3 data for global or longitudinal studies?
Whoever gave us the program costs for the mission, if that $180 million included launch costs, and how many years of operations is included in that. Thank you.
So whether we could launch, whether we could land.
I think
Question: How often?
that answers.
That
How often?
thrusted? Yeah.
How often do we collect data? I believe there are 12.7 orbits per day. So that's how many times we process the data on a daily basis.
Okay, thank you. This one has to do with the registration of the satellite. Jason-2 was UN registered by France. Is Jason-3 a U.S. registered satellite?
I don't know the answer to that.
Okay, well, we'll have to get back to that, an answer back to that question. That's what we have for now, George.
All right, we'll come back here for any additional questions here in the hangar. Steve?
Hi, just to follow up on the drone ship landing attempt. We obviously saw the landing live at the Cape. It was right in front of our eyes. Will we see anything live at the drone ship, or will we just hear about it, after the fact results of it?
We tried to bring this over live, but it's obviously out there in the ocean, and it's hard to get connection. We may not be able to do this. We'll do our best. And then likewise, I don't think you can see it from the land either. It's just too far below the horizon.
Yeah, I think we'll have another follow-up on social media.
Right. This is a local question. Barring weather concerns, will the launch be visible from the Vandenberg weather station area?
So it sounds like the question was, will the launch be visible from the Vandenberg weather station area? So I'm going to turn that over to Lieutenant Round because he knows where the weather station is.
Actually, it probably should be visible. From our actual compound that we sit in, you can't see the slicks down there. You can see Slick 2 really, really well. I mean, there's a grandstand out there. I don't believe you can actually see the slick, so you should see it once it clears the trees, a few seconds after launch. But no, I don't believe you're going to be able to see it actually sitting on the pad.
Any further questions? All right, that will conclude this briefing. Just a programming note that our launch coverage on NASA television on Sunday morning begins at 8 a.m. Pacific time. Thank you very much.